All right, we're back with part 4 of Blackjack. In our last one, we finished out the hand class. Probably one of our most notable methods is the get value, which will tell us the blackjack value of the entire hand, and it takes into account things like aces. We also wrote some simple methods that are going to help clean stuff up later on. Right? Is busted, meaning we've gone over 21. Have exactly 21 has blackjack, which is slightly different, and some casinos award more money based on that. Can double down. Doubling down is the action where you agree to take on only one more card, exactly one more card, and hopes to win more money. And then splitting is when you have cards of the same rank and you effectively separate them and play two hands. We also got started on player and got pretty deep in it. A player is going to have a name and some money. They're going to have an array list of hands. Keep in mind, I just talked about the action of splitting. That's why we actually have an array list of hands and not just a single hand. This reset method is going to be super important for getting my player ready for the next round. Basically, the main goal of it is to kind of discard hands. There's lots of ways to go about this, including actually leaving the hand intact but removing the literal cards from it. That gets messy. This is just the easiest thing to do, is that we just take our array list and tell it to point to a new array list, thereby getting rid of what we were looking at. Now, that array list does have to have a hand object in it. That's important for whenever we go to hit. So we have hit, which is how we basically get a card into the hand. Hit is actually going to go into the hands array list, get the element at index I, which is going to be a hand object. And so then we're hitting or adding the card to the hand. Okay, of course we got a two string and some getters and setters for our player. Let's finish out player because there's not much left here. We've done player, reset, get name, get cash, set cash, get hands, hit, hit, and the two string. We just need to do these split things. Okay. So here I have can split, which is just a simple check. As we're going to see, this is basically, we're going to say that a player can only split on their initial hand. That is, they can only split if they have exactly one hand. That one's a little bit easier to code than the actual split one, so let's knock it out first. All right? So we're looking at public boolean can split. We're going to return true if this player can split, false otherwise. I want to clarify that by saying that a player can split a hand if it's their one and only hand. If it's their first hand. Okay, so this is a limitation basically on the player. Keep in mind that the hand has a limitation to indicate if it can split or not as well. Okay, so this can vary per casino. Some casinos allow a set amount of splits, right? We would basically be saying we're only going to allow one split. Some casinos say that there's a higher number, like 4, 5, 6. And then some say you can do an infinite number of splits. Now, I guess thinking about that gets a little tricky. I feel like you can really only split like twice, right? If I get two tens, I'm going to split those. And the only way I can really split again is if I get, another 10 on either one of the hands. So the max I would guess is 4 technically. We're going to put in a simple limitation that we can only split once. It's just super easy, and I don't even want to think about doing multiple splits. So we'll say that a player can split if they have only one hand. How do I know? Well, that's if hands.size is exactly 1. That's it. Right? Keep in mind this is the array list that stores all of their hands. So we're saying if they have exactly one hand they can split. We'll combine this with the hand can split to determine if a split is actually possible. But simply put, right, this is the most important thing, that there's two cards and the ranks are the same. That's the most important thing with determining a split. But here in the hand actually has no idea about other hands that the player may have. Only the player knows how many hands it has, which is why we have this can split method here. Okay, so when we actually can split, we need to perform the split. So we're going to go public void split. What do we say? Okay, this is when a player has cards of identical ranks. We want to separate them, thereby making two hands. Okay. If we've hit this point, we've assumed that the player can split. Like we've already gone through that check. You can precondition, and if you want, precondition the player and hand can split. I would, in practice, be a little bit more detailed about what's going on here. But let's tackle this. I'm going to create some temporary variables to kind of clearly show what's going on here. Let's pull out the hand. I'm going to pull out the existing hand. Keep in mind, whenever this method is called, we already have a hand and both the cards are the same rank. I want to create a second hand, which is brand new. So this is the one that's got two cards. Has two cards with the same rank. This hand doesn't have anything in it. It's brand new, right? If we look at the constructor for hand, it just creates a hand with an array list, but there's actually nothing in it. So I have a hand that's ready to take on cards. What I want to do is basically take one of these cards, doesn't matter, they have the same rank, and put it into this hand. Okay, so I'm going to take hand 2, and I want to add to it. What I want to add to it is one of the cards from hand 1. Add's not the method we're looking for. That's an array list method. 2 itself is a hand. The way that we add cards is a method that we wrote called hit. Okay, so I'm going to take the hand. I'm going to tell it to hit, which will add a card to it. And the card that we're going to add is one of the cards from hand 1. And I would probably, it kind of makes sense to get the element at index 1. How do we get the card out? Well, we can pull out the cards array list. Right, this is a hand. Get cards is going to turn an array list of cards. That's the cards that are in here. I can then get one of the elements from here. The element at index 1 is technically the second card. I think that makes a little bit more logical sense. That is what's creating hand number 2. So I'm going to go into hand 1. I'm going to pull out all of the cards, which there should only be 2, and I'm going to get the second card, which is the element at index 1. That is a card object, right? This is a hand. This is an array list of cards. This is a single card. That is the card that I'm adding to this hand here. Okay, technically at this point, the card exists in 2 locations. It's still in hand 1 and it is now in hand 2. So I need to also remove it. Right, we would go into 1, we would get cards, we would get the element at index 1. Just kidding, we would remove the element at index 1. And that would get rid of it. Now I'm going to back that up for a second. If we look at our remove methods, right, it's overloaded. There's this version where we specify an object, right? I would basically need to know what card I want to remove already, like the literal card object. I don't really have that. What I do have is an index. So this is the version we're going to remove. But take a look here. Right? When I do this, it is going to remove. Okay, that is the whole purpose. But if you look, this is IntelliJ telling us that this is what it returns. Remove, when you specify an index, not only does it get rid of that object, it returns it as well. So what that means is this is a hand, this is an array list, and we're going to tell that array list to remove the element index 1. But what I have highlighted is actually the card that was removed. Here's the thing. I want that to go into hand 2, so I can actually do these things in one line. Following the order here, I know this can be a bit jumbled. We're going to encounter this method. We're going to go inside these parentheses, where we go inside the hand, get the array list, remove the card from index 1. That gets returned, and then it gets added to the hand via the head method. So not only will this line remove it from hand 1, we're also going to add it to hand 2 in one single line. Okay, so I've removed the card from hand 1, I've created hand 2 and successfully added the card there. But the hand just kind of exists here locally. Last thing I'm going to do is take my hand's array list. This belongs to the player. And we're going to add the new hand we just created, which is called hand 2. And that is our split. Let's see if we can check this thing out. I'm going to flip over to my driver. We got a player that's taking on a couple of cards here. Let's take a look at that. All right, so we see this is their hand. Why don't we do some matching ranks here? Take a look at what that is, and let's first test our. We'll test our player.can split. Can the player split? In theory, yes. True. They have exactly one hand. Okay, let's actually do the split. The can split is not actually necessary. The way that our method is preconditioned is that we assume that they can split. Hello? What did I do wrong here? Oh, I'm trying to print it and it's void. All right, let's do that and we'll actually see our player after the fact. So initially we're not going to have anything at all. We then tell the player to hit and we're going to split the hand. So take a look. This is hand 1. This is hand 2. In practice, we would then make the player hit on both of these hands or allow them to hit. Well, I guess they have to. But well, maybe they don't have to. I don't know what casino rules are. So we have 2 hands here. Now we coded the 2 string in the last video. I would argue here that this gets a bit jumbled, right? It's pretty obvious here that we got like some excessive braces, particularly the ones on the ends here. Okay, if I flip back to player, those braces are from including hands. They're just automatically there. We've seen this a lot. Right, whenever you actually print off an array list, those brackets are included. This is part of the array list 2 string. Okay, so what would be nice is just to get rid of those things. And actually, as it turns out, because this is ultimately a 2 string, right? We are implicitly calling the 2 string. I can explicitly do it here and we would get the same result. I can take this string and use string methods in order to get rid of the braces. I basically want to get rid of the first and last character, and we can do that via substring. I'm going to do a substring of hands.toString, which is going to be something like this. It's like, you know, it has cards in it. I'm going to do a substring starting at index 1. That just happens to be a 1. And I'm going to go up to this point. Okay, this can get messy, and in practice I would probably break it out, but we're going to go into hands, get the 2 string, and I need to know what the length of that is. -1. I would consider using some variables, right? We could create a variable to kind of store this. But you see, before we had brackets wrapped around this whole thing, and now not so much. This looks a lot cleaner. Okay, that's going to be it for player. The moment you've all been waiting for, we can finally get started on Blackjack. Let's take a quick look at the public interface. We're going to have a constructor. We're going to have to be able to add a player, play around, and then you see that we actually have a method that handles a single player's turn. Okay, let's get started on our constructor. We're going to have public Blackjack. It was a no args constructor. And let's think about what a game of Blackjack actually has. We're going to have players with an S, multiple players. One of those players is effectively going to be a dealer. So we'll actually make a player. We'll give it the name dealer because they participate in the game. They're the last person to always go. They're the last person to receive a card. A game of Blackjack also has a deck. In practice, casinos technically use like 6 to more decks kind of somewhat simultaneously. And that is to try to reduce card counting or something, or just try to reduce cheating as much as possible. Not a problem with us because our deck is so random to begin with. Okay. So let's get started with those things. Notice I'm saying that Blackjack has these things. They are properties, instance variables that Blackjack has. So Blackjack is going to have a deck. Blackjack is going to have an array list of player, which we will call players. I'm going to hover over this, hit Alt-Enter in order to import it. The dealer is going to be one of those players. And technically speaking, we could just remember what index the dealer is at, right? It's going to, in theory, be either the first or last. I recommend that we make the dealer the last element in this player's array list and keep it that way because we want the dealer to go last. We want them to receive the cards last. To make things clean and easy, I'm going to create a player variable called dealer. So instead of having to say something like players.get players.size -1 in order to just reference our dealer, I'm going to create this variable and tell it to point at the dealer object, the player that we consider the dealer. And so I can just go through this clean and easy, and it's going to make the code look a lot more elegant. The last thing I would consider adding here is a bet amount. So the way it works in the casino, and now that I'm thinking about it, this public interface is, yeah, there is a double there. That double is the amount of money that we want to bet each hand. So typically a table at a casino has an amount of money that it costs per hand. You know, $5, $10, $20 per hand is what you basically have to divvy up in order to even play a round. We're going to do that here. We're going to establish what a certain dollar amount, and in order for a player to play, they actually have to have that money available. So let's do this constructor. We have our bet coming in. We're going to use it to initialize our instance variable. So I would say this.bet is equal to bet. Easy peasy. We need to initialize deck. Deck is going to be a new deck. It's going to go into this class, call this constructor, which has an array list of cards. It'll fill it. It'll shuffle it. We got our deck. Okay. We're going to initialize, we'll go ahead and create our dealer, I guess. Dealer is going to be a new player. Keep in mind that a player needs a name and a certain amount of money. In theory, the dealer doesn't have money. I recommend putting in like a 0 here. And what that'll allow us to do is actually see how much money the dealer is raking in. Right? When the game starts, they start at nothing. We can actually see over the course of the game how much money the dealer has, and thus the net positive, how much money they've gained. Spoiler alert, the dealer's like 52% favored ultimately because they get to go last. And so that's how the casino makes their money. So in theory, over time, this is pretty much always going to trend up. Last thing we need to initialize is our players. Right? Players is going to be a new array list that consists of player objects. I want to go ahead and add a player. I'm going to go ahead and add the dealer. Okay, so when we create our game of blackjack, we've established this table is doing this amount in terms of betting, and we already have a dealer there. This is an array list though, so we can accept new players. Why don't we add that next? I need to be able to add a player. Right? Keep in mind that we have a blackjack object. Inside of that is where the array list is at of players. This is just the data structure we use to kind of organize these things, keep these things together. So in order for me to add a player to my blackjack, I need to go through the blackjack object in order to do that. We're going to just do a very simple players.add player in theory. Okay, remember earlier when I said it's going to be advantageous for us to make the dealer last and always keep them as last in this player's array list? That way, whenever we're dealing cards, they're the last spot, so they're the last spot to receive a card. Whenever we're actually playing the round and then the player is taking their turn, the dealer will go last because they're last in the array list. So instead of adding the player, which will append it to the end of the array list, I recommend let's just put the player up front. The add method is overloaded, so you can specify an index. I'm going to add the player at index 0. Right? Initially, the dealer is there, so that's going to put this new player in that spot, and it's going to shift our dealer. And every time we add a player, if we just put them at the front, it's going to shift the dealer further and further back, or always keep them at the end. That's essentially it. Okay. So, we're ready for the meatiest, beefiest method in this whole project, which is the play round. Okay. We're not going to get super deep on this, and that's okay. Whenever a round of blackjack starts, first thing that's going to happen is we're actually going to take the money from the players, right? You got to divvy up your money in order to play. Our table takes a certain amount of money. You got to have it. You basically sit it in front of yourself saying, hey, this is me. this is the cash I got. I'm ready to play this round. So I recommend let's put an indicator starting out. Right? We're saying new round. This is where everything begins. So I want to take the bets. I want to go through all of my players and subtract out the required bet. We'll do some checks later on to make sure that they have the money. In particular, we're going to come in and basically kick anybody out that doesn't have enough money. But when the game starts, you got to have the money. So let's loop through our players. I'm dealing with an object array list. And I find in practice, students hate for each loops. I don't particularly like for each loops, but once you start working with objects, the downfalls of for each loops, mostly that you can't really modify the element there, start to go away because it's no longer modifying what is in the array list. You're telling the object to modify itself. So for each loops actually start to become super clean. I'm going to say for each player, which we'll refer to as player in players. Simply put, we're going to go through the players array list. Each individual element is a player. And then here, this is what I'm going to call them for the iteration. Okay, so we're going to go through the entire thing. I need to subtract out the money. Okay, everyone's going to divvy up money. Everyone except the dealer. Okay, in theory, we could use a for loop and basically do everything up to the last element. Okay, that's one argument for using a for loop. But because we made this variable, it's actually super easy to skip the dealer. I'm going to put in a simple if statement check here. If the current player is not the dealer. This is clean. But let's talk about what's actually happening here. Player is a player object. Okay? Dealer is also a player object. When I'm saying not equals, what I'm actually testing, I'm not actually looking for equivalency. Right? That would actually rely on a player equals method, and I don't got it. What I'm actually doing is saying if the current player object is not pointing to the same thing that dealer is pointing at, right? Keep in mind, we got variables that point to objects. And what I'm saying is if player is pointing to something else other than the dealer, that must mean it's a different object. It is not the object that we consider to be the dealer object. Okay, so if this is true, this means this is somebody I want to take money from. I'm going to go into the player, and let's take a look at how we could possibly modify their money. We could consider including methods like decrement or something like that, but we have some simple getters and setters. I'm going to set the player's cash. I want it to be less than what it currently is. That is, I'm going to pull out their current amount, but subtract off bet. Bet, it's purple. It's one of these instance variables that's up here. It is the amount of money required to play a round. I'm going to set the player's cash to what it currently is minus the bet. Okay, we need to keep track of that money. We need to kind of know where does it go. In theory, it goes to the dealer. So I'm going to set the dealer's cash to what it currently is. I don't want to lose the money, right? I know it's 0 starting out, but over the course of the game of blackjack, it could change. In theory, it should go up. So I'm going to set the dealer's cash to what it currently is plus bet. And there you have it. Why don't we make a toString so that we can actually see what this looks like so far? So I'm going to say public string toString. And let me see what I got. Do I not have? Oh, that doesn't really look like something I do. So yeah, it was not on our public interface. So I'm going to create this toString for testing. And the main thing I care about is the players. We can include everything if you would like. Right? I could say something like bet plus my bet. I'm then going to create a new line using our new line character. I'm going to say something like deck. You could print off your deck if you want, if you really, really want to. This would be a good way to check to make sure that the deck is shuffled. Spoiler alert, it will be. The dealer. This will show us the dealer. And then lastly, our players. Okay, a couple things to keep in mind. This is a double. Easy. This is going to be a deck object. We wrote a toString for our deck, and so we're going to see that. Right? So here, whenever I say deck, we are implicitly calling the toString because we're trying to take an object and concatenate it with a string. That is one of the times, along with printing off the object, that is one of the times where we implicitly call the toString. Same thing here with dealer. Dealer is technically a player, so we'll go into player and call the player toString. And then lastly, we have players, which is an array list. So we're going to go into array list, call its toString, which is going to go through all of the objects, in this case player objects, and call their toString. So again, we'll call players toString, but for each player. I'm going to test this out in my driver. We got Bob. Bob can hang around. I'll end up maybe adding him to the game. He can hit a couple of cards. That's perfectly fine. Let's make our blackjack game. And we'll say that it takes a certain amount to play, 5 whole doll hairs. I'm going to take my game. I'm going to add a player, and we're going to add player, which in this case is Bob up here with 100. In order to kind of see what we got going on here, I'm going to print off my game. Let's tell this bad boy to run. And we're actually going to see 2 players in this blackjack game. Right, so initially I got Bob. I'm printing in here. Everything that we see down here, this is from that little toString that I just conjured up, right? Our blackjack game, you need 5 in order to play. Here is our deck, and we're calling the deck toString. And there you see all of that. There's 52 cards total, and they're shuffled. We see our dealer. Right here I said dealer in the actual blackjack toString. But we're also printing off the player name here from the player toString. Initially, our dealer doesn't have any cards. We didn't give him any. We will. Bob, however, we temporarily gave some cards. There's Bob. And then we see our dealer right there. Notice that the dealer is at the end. That's because I added Bob to the front, the element at index 0, and pushed other things. Okay. I'm back in blackjack. We have taken the bets from the people. Just kidding. I need to call the play round method. Game.playround. And in order to see this change, I'll print it off again. So we're going to get a before and after state on our blackjack. Right? First thing that happens, we have a new round that gets started. The dealer now has 5 whole doll hairs. And notice that that money came from Bob. There's only 1 player currently that's eligible to be played. But we took the 5 from them and gave it to the dealer. We basically skipped the dealer because the dealer's not going to have to cough up any money in order to play. The money's coming from the other players. Why don't we maybe add another player here? Oh, how about this? We'll make a Karen. And Karen's coming at us with like $50. No, did not mean to do debug. I'm going to run it without giving Karen any without giving Karen any stuff here. So new round. Oh, we didn't add Karen. Struggling. I am struggling right now. Let's add player 1, which is named Karen. And so we're going to see a before and after again here. Here's the blackjack game initially. Notice that Karen is at the front. Again, that's because whenever we add a player, they go to index 0, continually pushing the dealer towards the end. That makes sense to me. So Karen has 50, Bob's got 100, the dealer's got nothing. We play 1 round. Karen lost 5, Bob lost 5, and that money went to the dealer, who did not lose 5, only gained money. That's because we are skipping the dealer whenever we are taking the bets. Okay, I'm going to do one more thing and we will call it for the video. After we take bets from all the players, next thing we want to do is give them cards. So we're going to deal cards. So effectively, I want to go through each player and tell them to hit twice. Okay. And practice, the way that works at the actual casino is we do one card, 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 one card. I say that because one approach you could take, which just doesn't like track logically, is that you go one card, two card, one card, two card, one card, two card. That's just not how it's played in casino, right? They fan out one card at a time. Okay, so let's deal each player one card, and then I'll show you how you can easily make it two cards. I'm going to again say for each player, which we'll refer to as player and players. I want this player to hit. They need to take on a card. That card is coming from the deck. Right? We got this method, deal, I was about to say, deal, where we end up removing a card and returning it. So the player is going to hit, but it's coming from the deck. Not only is this going to remove the card, it's going to return it. So what I have highlighted is a card, which we are then hitting. We're giving it to this player. So I'm going through each player, giving them a card from the deck. Now that's only one time. I want to repeat this twice. Actually super easy. Again, one way that is somewhat erroneous is that we could just do this twice. That gives people two cards. But the way that this is we're going one card, two card, one card, two card, one card, two card. That is, I want to emulate the casino, the way the game's actually played. So this is giving the player one card. I want to just do it twice. I'm going to put that inside of a for loop. So to create a loop that's going to loop two times, just like that. Okay, so let's test it out in our driver. I'm going to flip back. I'm not going to give Bob cards. We're going to create these two players, Bob and Karen. They got money. They don't have cards yet. We're going to create our blackjack game, allow them to sit down at the table. We'll see the before, play around, and then we'll see the after. So when the game, so right here at line 12, whenever we print our game, we'll see the players. They're not going to have any cards, but they are going to have their money. We then play a new round, and you see that Karen has this, Bob has this, the dealer has this. They each have two cards. And if you actually look, here was the original deck. Right? The queen went to Karen. The six of hearts went to Bob. The queen of spades went to our dealer. The king of spades went to Karen. 7 to Bob, and then our 10 of diamonds to our dealer. So we went one card, one card, one card, two card, two card, two card. The way the casino does it. That is going to be a good spot to kind of pause this. And we will pick it up in the 5th and final video of Blackjack. I'll see you in the next one.